First of all, welcome to our monthly Apache Sedona community office hour. And usually during our office hour, so we will have some specific topics to discuss, such as the latest progress of the community and the recent release of Sedona, and also some interesting tutorials, some introduction about features, and also communicate about so how can we collaborate to develop Sedona to make Sedona better software. So as usual, let's quickly introduce what Sedona is. So Sedona is an open source cluster computing engine for processing big geospatial data. So we have a website, and we have our GitHub repository under Apache Software Foundation. And we also have our Twitter account. We also have our Discord server. So if you don't know what our Discord server is, please ping us in the chat, and we will send you the link so you can join the Discord server. So basically, Discord server is going to be the best place for you guys to post questions, to communicate with fellow community members, and learn the latest news of Sedona. Maybe Ben or Will, do you mind if you post the Discord server link, invitation link in the chat? So the status of Apache Sedona. So as you can see on your right-hand side, so many companies have been using Sedona in production, and the Sedona was a project started in 2015 as a research project from Arizona State University. And it became mature in 2017, and it joined the Apache Software Foundation in 2020. It has over 10,000 of corporate users. On GitHub, it has over 120 contributors. It has 1,800 stars on GitHub, and currently it has over 1.5 million downloads last month. And so far, it has 30 million total downloads. And is according to its downloads, Sedona is ranked among top 0.3% most downloaded package on PyPy. So a quick overview about the system architecture of Sedona. As you can see here, the diagram on your right-hand side. So Sedona has multiple layers. So on top, it supports many developer tools. You can connect Sedona with Apache Zeppelin, Tableau, Jupyter Notebook, GeoPandas, and RStudio. And after that, Sedona has this layer called Spatial Query Processing layer. In this layer, we provide a number of different language bindings, so Scala, Java, and the Spatial SQL, Python, and R. And the Spatial Query Processing layer equipped with a bunch of distributed spatial query algorithms, as well as an advanced spatial query optimizer. So that means, so whenever you give Sedona a spatial query, Sedona will be able to automatically decide what is the best query algorithm to process this query in the cluster. And it will automatically distribute the workload to all machines in the cluster. So under the spatial query processing layer, Sedona has this thing called distributed spatial dataset layer. So it equips multiple distributed spatial data structures to speed up the query performance. For example, it has the spatial data partitioning, spatial indexing, spatial data compression, many different techniques. It runs on multiple distributed engines. So it runs on Apache Spark for batch processing, as well as the stream data processing. It can also run on top of Apache Flink for stream processing. It also runs on Snowflake. So we also provide a native app called Sedona Snow over Snowflake Marketplace. However, among all the support, all these engines, so Sedona provides the best support on Apache Spark. Okay. The releases. Sedona follows the 3-month cadence for their release schedule. So last month, as you probably already saw, we made one release called actually made two release, 152, 153, and the 153 is actually a bug fix. 152 this is to fix a critical bug in 152, which introduced geopendence as a required dependency. Another major release we made last month is 160. It was made on May 15th, and I'm going to talk about that later on. And the last release was made, the release 151 was made in January, right? As you can see, we roughly follow the 3-month release cadence. Okay. I also want to share a few recent community blog posts to you guys, just in case if you guys are interested, and this will help you guys learn. So how can you make use of Sedona and also know how the community work with Sedona to make it a better world. So one blog post our community member recently posted is called Making Overage Maps Data More Efficient with GeoParquet and Apache Sedona. So I'm not sure if you guys have ever heard of Overage Map Foundation. So Overage Map Foundation is a nonprofit organization that released open geospatial data to the world for free use. And as you probably already know, Overage Map data start to adopt GeoParquet format. All their data released are actually made in GeoParquet format since October or September last year, right? And they actually use Sedona to prepare the entire dataset and save the dataset in GeoParquet format. And our community works closely with the Overage Map Foundation to help them prepare this dataset. In particular, this Overage Map GeoParquet files has the following features. So first of all, it has this thing called, in addition to the geometry column, it has this column called the B-box column. So that means it has a specific column that contains the min and max x and y of the geometries. And in addition to that, it also adopts this two-level geohashing. So first, it has a coarse grain geohashing at precision level 3. So the idea of this geohashing is they partition each GeoParquet file to around 1 gig size based on the level 3 geohash. It also provides a finer level geohashing, use geohash precision level 8. So this finer level geohashing is to store data within each GeoParquet file. So that way, you can still leverage the ordinary Parquet reader to do filter pushdown based on the B-box column inside each of the GeoParquet file. So in short, the GeoParquet file from Overage Map data has 3 benefits. So first of all, you can download individual GeoParquet files from OMF without a Parquet or GeoParquet reader. So you can do this by using AWS S3 CLI. You can actually list the file structure, the folder structure of the Overage Map data. And the folder is actually named after geohash ID. You can simply look at those ID and then download the data you are interested. Secondly, as I probably already mentioned before, so GeoParquet equips with this thing called B-box statistics in the GeoParquet file metadata. So that means you can actually use a GeoParquet reader to read GeoParquet files and filter data based on the B-box statistics in the metadata of each GeoParquet file. And in addition, the third benefit is you can still use standard Parquet readers to filter data based on the B-box column. As you already mentioned, so Overage Map GeoParquet file introduces this additional column called bbox column, right? So without bbox column, if you don't have a dual packet reader, you won't be able to perform spatial filter pushdown. But now with this bbox column, you can do that. So the URL of this community blog post is down here, as you can see here. If you're interested, you can take a deeper look. Okay. All right. Another recent community blog, processing a billion aircraft observations and combining with weather data using Apache Sedona on Veribus Cloud. So this is a very interesting blog post. What it does is it collects a bunch of aircraft observations, right? Both domestic air flight observations and international flight observations. As you can see here, so you can visualize the trips of the aircraft observations using H3 grid. You can show the density of the flights, and you can also show the land string shape, of the aircraft observations, the flights. As you can see here, so there are many flights that fly between United States and Europe, right? And in addition to that, in this blog post, it also collects lots of weather events data, including such as raining, snow, wildfire, all these kind of weather events. And what it does is it joins those flight trips together with the extreme weather events to figure out, so what are the flights or what are the routes that can be that are frequently affected by extreme weather events. So that way you can better plan your like your flight, right? So this is about this blog post. It is a very interesting blog post. It actually shows the scalability of Apache Sedona as it actually process a billion aircraft observations. It also joins those aircraft observations with a huge amount of weather events. Oh, right. Another interesting thing I want to talk with you guys is actually the Sedona Docker image. So Sedona has been releasing this Docker image for quite some time, and you can find this Docker Hub Apache Sedona image on Docker Hub, and you can pull it and you can play with it. And this Docker image contains a Jupyter environment that allows you to directly open Jupyter Notebook in your local browser and play with Apache Sedona. So Sedona Docker image is the best place for you to play with Sedona on your local machine. And also it is the best place for you to learn how to work with Sedona, right? Without actually needing to deploy Sedona to a cluster environment, right? So it can help you do lots of interesting work on your local machine. I actually want to also show this to you guys. Let me open my browser. All right. So I already started my Jupyter environment, my Docker image. And if you start Docker image using the command I show it here, right? You will be able to put the image, and then you can run this image. And in your terminal, it will have something like this. Now, if you open your browser, you'll see something like this, right? You'll see an example folder. It contains a bunch of example notebooks for Sedona, right? So there are multiple notebooks. For example, Sedona core notebooks that explain how to use Sedona core functions, in particular those RDD functions. So the Sedona RDD APIs are for you if you want to hack into the Sedona kernel, if you want to customize the special queries algorithm, right? You can use the Sedona RDD API. We also have raster notebook. So the raster notebook demonstrates the raster data processing capability of Sedona, such as the RS functions. And we also have the Apache Sedona SQL notebook. In particular, this is an example about the spatial join of Sedona using the spatial SQL API. It shows a spatial join between airports and countries. And there are a bunch of other notebooks. So if you are interested, please feel free to play with that. In particular, today, I want to talk about a few interesting functions in Sedona and use this Jupyter Notebook environment. So first of all, I want to demonstrate the UDF functionalities in Apache Sedona. So UDF is a very important and very interesting functions offered by Apache Sedona. Sedona has a very good integration with Python Shapely, GeoPandas. It also has very good integration with Rasterio and NumPy. So that means even if there are some functions are not provided by Apache Sedona natively, you can always use Shapely UDF to run similar functions on Apache Sedona in a distributed manner. The same thing also applies to Rasterio and the NumPy integration. So all this are made possible through Sedona advanced distributed computation architecture, as well as our very advanced serialization and deserialization functions. Now, in particular, let's look at this Rasterio and NumPy integration. Okay. In particular, I'm going to show you how to write a Python UDF that take a raster object from Sedona and perform and call NumPy API, perform some operations, and similarly write a Python UDF to perform operations on raster object, use Rasterio functions. Now let me open this Jupyter Notebook. In this case, I'm using the Sedona raster notebook, right? So if you are on the same page with me, you can go ahead and click Run Ourselves. Let me just run that. So I can quickly go through the content of this notebook. So what it does is it first creates a Sedona context. And in this case, it is connected to the local host because it used my local machine as the studio cluster. Now I'm going to read the GeoTIFF file. In this particular case, since this is a very simple demo, it reads the data from this particular path. So data raster folder, right? It has a single GeoTIFF image. You can load it, use the Sedona binary file data reader. And after you read that, you can convert that one to a raster data type column, use RS from GeoTIFF function. If you actually show the schema of this function, this data frame, you can see, so this is actually a raster type column. You can perform many interesting operations on the raster data, use Sedona. For example, you can use RS metadata functions on this raster image to fetch the metadata of this raster image. For example, in this particular image, this actually indicates the boundary of the image, the spatial boundary of the image, and also the coordinate reference system, so on and so forth. You can also visualize this raster image inside your notebook. you can use Sedona Utils display image, and as you can see here, so this is the raster image we are working on right now. And interestingly, you can also join those raster images together with vector data. So this is a very unique feature offered by Apache Sedona. For example, as you can see here, you can use this predicate called rs_intersect. You can join the raster table and the geometry table together, and you can use rs_intersect to verify the spatial relationship between the raster image and the vector geometry. So basically, this will tell you that, so what are the raster images intersect with the geometries. So there are many other functions here. I won't go through all the details. In particular, as I mentioned, I want to show you guys the Python UDF. I'll jump right to the Python UDF here. So given those raster data frame, here I implement Python UDF, and it actually calls the NumPy API. In Sedona raster functionalities, we provide a function called as NumPy. So what it means is that, so for this UDF, if your input is a raster image, right, you can directly call this as NumPy to get a NumPy array out of this raster. You can call whatever NumPy API you want to use. For example, in this case, we call the mean function. The mean function will calculate the average value among all pixels in this array or in this image. So this is very simple NumPy UDF. We do this, and we register that, and we directly give this raster column to this NumPy image, to this NumPy UDF. As you can see here, we have in the output, we have the raster column. We also have the mean pixel values for the entire raster image. As you can see, it is very easy to use. Similarly, we can also use the rasterio UDF. So basically, given an input raster object, you can call this as rasterio function to get a rasterio dataset reader. And in this dataset reader, you can call whatever rasterio API you want to use. And in this case, we call the shape function that actually tells us the x, the width and the height of the image, right? So I register this user-defined function and then apply this to the raster column. As you can see here, it gives you the shape. In this particular case, I use 2 images. It will tell you the shape of each image. Again, this function works with any number of raster images. You can have like millions of raster images, and you can apply this UDF to all these raster images using Sedona. This essentially make rasterio or NumPy a distributed cluster computing system. Another interesting UDF I'd like to show you. This is something we have had for a very long time. It is the Shapley UDF. So this is for the vector geometries in Apache Sedona. As you can see here, I'm implementing a Python UDF. The input is a geometry type, is a Sedona geometry type. And you can directly call whatever Python Shapley functions available to this geometry, because this gets converted internally to a Python Shapley geometry object. In this case, we call the buffer functions that offered by Shapley natively. So we call this buffer function and return it. So this is a very simple Python UDF, but it is very powerful, give you lots of flexibility. You register these functions, right, we call it the buffer function. You can apply this to your vector geometries. And as you can see here, so this was the original geometry data frame, and we calculate the area of the geometry, the polygon geometry, right? And we apply the UDF, the buffered UDF on this polygon geometries, and then we count ST area, as you can see here. So the area now is much larger than the one here. All right. So this is just a very quick demo of Sedona Docker image and some interesting Python UDF in Apache Sedona. Now let's move on to other functions, other topic in this slides. All right. Since we just made the new release of Sedona 160, now let's go through the interesting features of this new release. First of all, so this release was compiled by Java 8. So we initially wanted to make it compiled by Java 11, but after we post this message on our community, so we received lots of feedback, and we noticed that many people are still on Java 8, unfortunately. So we decided to revert that change and still put Sedona in Java 8. So I saw there are questions here. Is there a way to store the Sedona vector data frame in some cloud storage as data catalog and build a query engine and pipelines make it just query? Absolutely. So any Sedona vector geometry data frame can be stored in Parquet files and or in GeoParquet files. You can save it in S3, and that is actually how many of our many of our users are using Sedona. They save our vector data frame to Parquet and GeoParquet. And save it on S3, Azure, Block Storage, and Google Bucket. Cool. So first, let's go back to the release topics. So 160 compiled by Java 8, and it supports Shipley 2.0 in Python. It supports GeoPandas 0.12. It basically allows you to convert any Sedona data frame to GeoPandas. It can also convert any GeoPandas data frame to Sedona data frame. That means whatever data you have from GeoPandas, you can directly convert it to Sedona and make it run in parallel to have the performance benefit. Another interesting feature in 160 is the strong geography support. If we have time, I'm going to also quickly go through the strong geography support we recently added. And of course, the rasterio and NumPy integration with Sedona raster. Okay, let's look at a few vector functions introduced in Sedona 160. So first of all, so we added very strong geography support. So the first function we added is the ST best SRID. So what this function does is it actually automatically decides what is the best SRID for you to transform your data. Assume your data was originally in WGS84. It will automatically decide what is the best SRID. Right? You can transform your data to the CRS. You can do better, more accurate calculation there. Another interesting function is called ST cross data line. This will actually, if you apply this to your geometry functions, it will accurately detect if you have a geometry that crossed anti-meridian line. If that is the case, it will return true. Otherwise, it will return false. The reason why we add this function in particular is because there are many applications or many software are not able to handle geometries that cross international data line correctly. So it is better to provide such a function that helps people to detect these kind of geometries and perform some special treatment on that instead of just give you guys the the lazy software to give you guys the wrong result. Another function is called st_shift longitude. So what it does is, so it actually flip the coordinates of geometries from -180 to 0 to positive 180 to 360. So this is actually to mitigate the problem on geometries that cross anti-meridian line. So this is a very interesting function, and if you guys are interested, please find it in Sedona's documentation website. Okay, another function, st_division spheroid. Sedona has been supporting spatial distance drawing for a very long time, for a couple of years, and we also support st_division and also distance drawing using st_division. One interesting function when we add in 160 is that so you'll be able now to use meter distance directly in st_division. Okay. In the past, if you do st_division based spatial drawing or any kind of like filtering query, so the distance you specified is actually agnostic. It is actually using in the same unit of your input CRS, right? So in that case, sometimes it is kind of hard for people to perform these operations on meter-based distance, right? So recently we added this support. Now with this function, you won't need to transform your data first to the CRS that you want to use, right? You can directly use meter-based distance in st_division. So similar thing in st_buffer in the past. So the buffer you specified in st_buffer function, it is in the same CRS of the input data. So sometimes it is a bit hard for people who use geography data to use meter-based distance. So that's why we add st_buffer. So there are a couple other functions, st_snap, st_polygonize. So st_snap is to snap the vertex and segments of geometries according to the geometries of another, according to the vertex of another geometries. As you can see in this example, so the shape of this polygon is actually snapped to this line, this green line. Another interesting function, st_polygonize. So this is particularly useful for people to create polygons formed by the line work of a set of geometries. Say you have a bunch of line strings collected from your OSM neural network, right? And the st_polygonize will help you to form a geometry collection out of those line work. And new raster functions. One interesting new raster function we recently introduced is RS interpolate. So here is an example. So suppose this is your original raster image. In this raster image, it has many interesting, like it has many null values, no data values in the original rasters. And it only have a few observations like this, right? The small colored pixels. Now, st_interpolate is to estimate cell values by averaging the values of the sample spatial observations, right? As you can see here, this is interpolated raster. So the idea is you want to estimate the value of each pixels based on the few available spatial observations. Another interesting function, RS reproject match. So basically, this is a function. This is a function that is available, actually similar to the function available in rasterio X-ray. So what it does is you have a bunch of raster images, right? Many of them, they might be looking at the same location at different timestamp, but in fact, their spatial extent is slightly different due to the inaccuracy of the satellites, right? So the reproject match actually take two raster image as the input. It reproject one raster image to match the georeference, CRS, and the bounding box of the other reference raster. In particular, if you look at this example, raster 1, raster 2, if we use raster 1 as a reference image, and we reproject raster 2 to raster 1, so this is output. This is output. So similarly, if you do it in reverse order, so this is the output. As you can see here, you can reproject one raster to another to match the spatial extent and CRS. So that way, you can compare raster images from different time step. Cool. So this is about a few interesting functions here. So the final thing of this community office hour is, again, to call for help from the community. So as we have many people attending this meeting here, so I'd like to call for help from you guys to help us improve the Sedona community. As you probably already know, on Sedona GitHub repository, we have many notebook examples, right? It will be great if you have very interesting notebook examples, applications, use cases. You can submit these notebooks to our use case here, right? So this will help us improve the examples. This can also help you to showcase your own applications to our broad community. And also documentation website update. We always welcome people to help us update our documentation website. So even if this is it is just a typo, even it is just to like add a few more sentences to the documentation, right? So any contribution is welcome to our documentation website. The third thing is the release test. So in fact, whenever Sedona want to make a release, we always go through a voting process for the binary release as well as source code. So this is required by the Apache Software Foundation, and this is to ensure that so we go through a democratic process in the community, right? And also to eliminate the possibility of having severe bug in the output in the release. So usually in the voting process, we verify the signature of each binary release, perform some basic test on the binary files to prevent some bugs from happening, right? So we always welcome the community to help us test those releases. When a voting process starts, it usually lasts for until 3 days. It will be really, really great if any of the people here can help us improve the community. All right, so I think that's all I want to present today. Now, in the remaining 10 to 15 minutes, I'd like to have all you guys ask questions, and we can also do some sort of like roundtable introduction just to get to know each other, right? So let me see. Okay, so first of all, let me do an intro myself. So this is Jia. I'm from Variables. I'm also the PMC chair of Apache Sedona, right? So I'm leading the development of the open source community. Let's see who is next. So Ben, do you want to introduce yourself?
Sure, happy to say hi. I'm Ben Pruden. I'm with Whereabouts as well, working with Gia and Will and some of the other folks on the call here today.
Thanks, Ben. Will, do you want to introduce yourself?
Hey folks, my name's Will. I work at Whereabouts on the developer relations team. So my job is to help support the community, both for Apache Sedona and of course folks using what we're building at Whereabouts. So feel free to reach out if there's anything I can help folks with or get you started.
Thank you, Will. Christine, do you want to introduce?
Yeah, hello everyone. This is Christine, and I'm also working for Airbus, and I'm also contributing patches and working on features for Apache Sedona. And there are several features such as the Shipley 2.0 support and some other features. For example, the raster integration, all my work. I hope you will enjoy these features.
Thank you, Christine. Okay, so I will just call the name randomly. Luke, do you want to introduce yourself?
Hi, I'm Luke. I work for DEFRA in the UK, and I'm just here to sort of see updates that are being made to Sedona to sort of relay back to my team.
Yeah, welcome. Welcome to the community.
Thanks.
Cool. Mike, do you want to chime in?
Hi, everybody. I'm just trying to keep abreast of what's going on and keep up to date on the newest technologies. I think Sedona and their performance that you're seeing is kind of a game changer. So I just want to keep up on what's going on in that space.
Thank you. Welcome to the community.
Yep.
All right. Aaron, do you want to talk? Okay. Let me see. Okay. Sanchit, do you want to introduce yourself?
Yeah, sure. Hi, everyone. So I'm Sanchit Agarwal, and like I'm working as a software engineer at AI Dash. So
Welcome.
So I'm currently exploring Sedona. Basically, currently we are using GeoTrellis for processing raster kind of data. Now we are doing the POC on Apache Sedona and looking to have some insights on how Sedona works and will it be good for our use case. So yeah, so mostly we are in POC phase, and like I am trying to know how Sedona works and what are the functionalities Sedona provides under the hood.
Cool. Cool. Excited to have you here. So again, if you have any questions when you use Sedona raster functionalities, the best way to reach out to us is you can reach out us through mailing list. But if you want to interact with us in real time, so please feel free to hop in our Discord server and post questions there. So we have a big community there that can help you and answer questions for you.
Yeah, sure. I'm already on Discord and I've
Oh,
already asked questions. So yeah,
nice, nice. Cool.
thank you.
Next one, Abraham, do you want to speak? Okay, so let's move on to Amelia. Are you there?
Hi. Yeah.
Hey.
I'm a PhD student at the University of Cambridge, and I study computer science and plant sciences. So I look at remote sensing of tropical forest degradation and deforestation. Um, I use Sedona a lot, and I've been doing stuff to kind of like teach other folks in environmental science and ecology who have less of a computer science background about Sedona. So I'm really excited to see these new features because a lot of them, especially the geography, is stuff that I think will help people out a lot.
Thank you. Thank you. And again, if you run into any problem, feel free to let us know. And if you have any good use cases you get when you communicate with your colleagues, feel free to reach out and create PR on our website to add your own use case.
Yeah, sounds good. Thanks.
Thank you. All right. Furkan, do you want to introduce yourself?
Hello everyone, I'm Furkan and I've been part of this community and I've been part of Verabot since last July, and it's been wonderful to be part of this. I contribute like the ST functions and raster functions throughout my time over here. And yeah, thank you, Jay.
Thank you, Furkan. All right. George, do you want to speak?
Thank you so much. I'm George Odero. I'm currently working as a GIS developer. I'm located in Kenya. I'm also trying to add this new technology. I'm working with Apache Sedona capability to process some geospatial data sets. So I'm learning on how I can improve the processing capabilities of this big geospatial data. And I think this new tool will be a good advantage to me.
Oh, glad to hear that. Again, feel free to reach out for help if you run into any problem. Cool. Pranam, do you want to introduce yourself?
Hi guys, my name is Pranav. I work at Verobots as well. I get to contribute to Apache Sedona often, working on raster and vector functions. I love to hear your thoughts on the use cases and really love the interaction here. Thank you.
Thank you, Pranam. All right, guys, we still get about 9 minutes left. So I will just use this as an open discussion. So feel free to ask questions and we can discuss and we can talk about that. Otherwise, you can, if you don't have other questions, please feel free to leave. But I will stay here until 9 a.m. Questions from Mac?
Jay, on the RS interpolate function that's new, can you change the kernel that's used for that interpolation, I mean?
I think right now we only have one kernel.
Okay.
Pranav, so you actually implement this. Any suggestions?
Sure. So you would still be able to use it on a bigger cluster in case your workload demands that.
I think Mac means kernel means that
Like,
different algorithm
Yeah, like different moving
sampling.
window.
Yep.
Oh, I see. So this is only a single kernel implementation right now. It works on IDW. So it checks the density of the valid pixels around the node data pixel and estimates and interpolates. So yeah, it is only a single implementation right now.
So it's just the inverse distance weight kernel?
Yes.
Okay.
Yes, that's right.
It'd be nice to be able to change that kernel to like a 6x6 or something if you were just trying to, say, take LiDAR data, rasterize it, and interpolate between missing values. That would be nice. Just to
Yes. Oh, I see. You mean the distance that it considers in the IDW calculation? Is that what you meant?
Yeah, or just be able to hard code like an actual moving window.
Yes, so that is possible actually. So there are two parameters that you can manipulate according to your needs. One is the distance, which is the radius around the node data pixel. So
Okay.
you can, for example, have 6-pixel distance. And another one, I think, is the min points parameter.
Okay.
So that factors in the minimum number of valid points around the node data pixel. And that's how you can basically configure.
Cool. All right, thanks. Appreciate it.
For
Yeah,
the
just
moving
give-
window use case, oh, sorry, Gia.
Yeah, so you guys can find the exact signature of the RS interpolate by searching Sedona website. So this is the exact signature.
Gotcha. Yeah, okay. Yeah, I just found the reference. All right, awesome. Thank you for that.
For the moving window use case, is that something you could use the map algebra function to accomplish? So the map algebra function allows you to define sort of a script to access other cells in the raster to define the value of each raster cell. That
Gotcha.
might be possible with that GIFL script.
Mm-hmm. Okay, I see that too. Yeah. Yeah, I sometimes I have a case where if you have like raw LiDAR data and you convert that to a raster, you end up with no data cells and you want to interpolate. And depending on how much smoothing you want to do, you sometimes it's nice to be able to manipulate that window. If you're making digital surface models or building models or things like that. So um, that's just interesting to see that you could do it. Good documentation.
Thank you. Thank you, Mike.
That's all I got.
Cool. Guys, feel free to raise your hand and ask questions. Bill, saw you raise your hand.
Yeah, I just wanted to mention something. So earlier, Gio was talking about that blog post looking at analyzing billion flight observations. And you were also mentioning the functionality for creating user-defined functions with Shapely or Rasterio. And in that blog post, one of the examples that we use is creating a Shapely UDF to interpolate these very long flight routes. So we sort of take point geometry to build up the path of a flight route, which can be several 1,000 kilometers long. And we're trying to identify weather event impacts in that. And we thought it'd be much more useful to break up those long geometries into uniform segments of like 100 kilometers. And so we did that by creating a Shapely UDF that uses Shapely's interpolate functionality. I tried to get that working in just spatial SQL, but I couldn't quite find an easy way to get the right evenly sized segment. So if you're interested in seeing like a sort of real world use case for when you use those UDFs, there's an example in that flight blog post, which I hadn't really written one of these UDFs using Shapely before, so that was super useful in this case. So just wanted to point that out.
Thank you, Will. Question from George. George, please.
Okay, thank you once again. I was trying to ask some question where we want to reclassify a raster dataset. For example, let's say an NDVI. I was trying to check if there is any functionality or any tool from Apache Sedona that we can use to reclassify this feature into certain classes.
Cool.
Is there that functionality?
Cool. So, speaking of NDVI, right now you can use Sedona raster map algebra to perform the NDVI operations. So let me paste this link here. And here is the example I'm talking about here. You can, if you have a raster image that has multiple bands, you can use our map algebra to calculate NDVI of the raster image. But regarding reclassify, I think right now we don't have a function that can directly reclassify the raster image to a particular class. And this is what you want, George, right?
Yeah, that's what I want.
Do you have some sort of like a reference or some sort of like example functions you are interested? You can share that with us and we can try to implement this in Sedona.
Yeah, exactly.
Yeah, do you have something? If you have, you can paste it in the chat or you can paste it on our Discord channel.
Okay. Let me do so.
Sure, thank you. Yeah, I will try our best to introduce this function. Sanchit, question?
Yeah, just one question. So I think like few days back I was exploring Sedona and like I was trying to store Sedona data frame in some kind of open table format like Iceberg. So I think I was able to do that, but the challenge was that I have to convert that geometry format into the basically binary format. So I was able to store the Spark data frame, Sedona data frame into the Iceberg format, but there was no geospatial indexing support. So is there any way we can do those things? Like, is there any? Yeah.
Yeah, this is a great question. Great question. So right now, direct answer is no, because Iceberg has no geometry data type. So there's no way that you can save a Sedona data frame or Spark data frame with geometry type directly into Iceberg. However, the good news is we are working with the Iceberg community to add the geometry support into Iceberg. And we already submitted a proposal to the Iceberg community GitHub repository as well as their mailing list. So there is a discussion going on right now. And on the other hand, so in particular in this proposal, we introduced two things. So first of all, the geometry data type in Iceberg with partition transform with native performance filter pushdown, and also one of the most important things we introduced is the integration between Sedona and Iceberg. So if you use Sedona Spark with Iceberg, so we're going to introduce a native integration that actually allows you to directly save Sedona or Spark data frame with geometry type column to Iceberg, as well as you can perform very efficient query processing or index on the Iceberg table. This will be out in possibly because there is a discussion still going on. So this will be possibly completed in the second half of this year.
Oh, okay, got it. I think yeah, I saw some post of yours on Iceberg community as well.
Yes,
So
that is a place where we discuss that. So if you're interested, so there is actually a GitHub issue that mentions this, and we are actually discussing that in that Google Doc, and we're also discussing that on the what's the name, the mailing list, Iceberg mailing list.
okay. Yeah, I saw that MOM doc as well.
Yep. You probably already saw my message there. So if you're interested, you can participate in, you can, speak up.
Okay, sure.
All right, folks. Actually, time's up, but if you guys want to stay here, I can stay here longer and continue to ask questions. And otherwise, feel free to leave. I don't want to hold you guys up. Amelia, question.
I just had one minor, I guess, feature request, which is about HDF5 files. These are often used by NASA, and they're not, as far as I could tell, like supported by Spark RDDs in Python specifically. Is that still true? I couldn't tell if that documentation was just old. Is there a way to use Sedona to get Sedona to read H5 files quickly?
Yeah, this is a great question. So I think the RDD-based HDF5 reader has been deprecated for years. And in about half a year ago, so we introduced a data frame-based, a SQL-based NetCDF reader. So let me send you the documentation in the chat. Let me see. Right here. Basically, you're gonna use the binary file reader to read those HF files, and then you're gonna use this function called rs from netcdf to read those HDF5 file.
Okay. I can't, I'm not sure if I can see it in the chat, but that if you have
Oh,
that
really?
documentation, that's, yeah, well, it says chat disabled for me, but maybe,
Oh. Ben or Will, can you look into this?
Yeah, maybe the
Oh, it only sends to panelists. Okay, my bad. Yeah, it is actually. Oh, I'm not able to share it with the attendees. So all the messages we have been posting so far now is available to the attendees actually. Okay, let me post it in the Q&A section. Probably that is better.
I think it's still only hosts and panelists. Well, maybe it,
yeah, I think I checked. I think I just updated it. Can you try again?
I don't know, still seem to be host and panelist.
Gia, there's a toggle you can shift to everyone on the to column.
Oh, yeah, now it is here.
perfect.
Sorry, wrong link.
Okay,
It's this
thanks
one.
so much.
No problem. Yeah, keep us posted. So if you run into any problem, let us know.
Okay, sounds good. Thank you all so much.
All right, guys. If you don't have any questions, I'm gonna leave. I'll stop here. And thank you guys again for coming here and talking to us. And we are very excited to have you here. And anyone is welcome, and any contribution is welcome. Thank you, guys. Have a nice day.
Good job.
Bye-bye.